Read code question number 721, account merge. This is medium question. Let's get into it. Give a list of count. Each element of count I is a list of string, where the first element of count I, 0, is name, and the rest of elements are emails, representing emails of the count. Now we would like to merge this account. Two accounts definitely belong to the same person if there is some email that is common in both accounts. Note that even if two accounts have the same name, they may belong to different people, as people could have the same name. A person can have any number of accounts initially, but all of their accounts definitely have the same name. After merging the account, return the account in the following format. The first element of each account is the name, and rest of elements are email in sorted order. The account themselves can be returned in any order. Okay, let's check with example 1. We receive this account. Okay, there is 3 John and 1 Mary, and I think Mary is okay because there are no duplicated, but John is the duplicated, so we are able to merge it between them. So let's check the email. So first and third John is share, so we easy to find these people and this people is the same. So return must be merged this one, and then this one is different because this one and this image does not share. So return is this one. Does this make sense? Okay, how we gonna do? Okay, I think there is the 2 approach. First is the DFS, and then another is union find. Today I'm gonna use union find because union find time complexity is better than DFS. So my approach is, first I will group with the email, and then if there are the same email, and then I will put the same group. To do that, I'm gonna use the several hash table. Some hash table is change email to ID, so because I group by ID. Then second is to converting get the name by email. Okay, okay, let me implement, and then I'm gonna explain while implementation code. Okay, let's start. First, I'd like to make a template of a union find. There are two approaches to implement union find. First, to use array, and then second is to use hash table. If we implement with hash table, not only code is simple, but also there is no limit for the space. So today I'm gonna show you how to implement with hash table. First, I will make the parent. Make a hash table, and then I make 2 things. First is find, and then second is union. Need 2. Okay, first, if one is not same is parent one, that means this parent does not this one is does not update with the parent one. At that time we need to update the parent one. Parent one must be find parent one, and then return parent one. This one is the updated parent one, so sequence is first we receive one and then it compare with each parent, but this one is different. I will do recursion. At that time this is the root, and then this is children, and then when value is here, this one is does not sync, group is sync with parent. I will try to find this one is sync no, sync no, sync yes, sync, and then we get this value input here with this operation, and after finish that, this one sync here, here, here. So finally we return this one. Does this make sense? Okay, now union. To implement union, we need to one method of dictionary, the provided by Python. That is parent is set default. Is if one is missing, I will return one. Another set default, 2 is missing, return 1. That means we're going to parent, but parent is that did not find me. That means this one is parent, right? This one is root. That is eldest ancestor. So in this case, we return this one itself. Does this make sense? But 2 is a little bit different. If 2 is ancestor, that is root, it must be get 1. That means this one is going to children of one's parent. So finally this one is the one group. Does this make sense? So that is the reason. If 2 is if we cannot find key 2 in parent, we return 1. Okay, and then now we do parent 1, just 1, no, find 1 to get parent value, and then that it we will put find to value. And then now let's implement the code. First we need email to ID, and the ID must be group ID, and the second is email to name, because we needed to find the username by email. And then next we need the counter index. Index is 0, because if the index is does not find, we use this one and then increment to next. This is for auto increment sequence. Okay, let's make one by one. First we get account from account, and then name must be A0, right? This is name, and then email is from 1, right? So for I in range 1 to length A, and then email must be AI, right? So this is the first email and the second email. Now we put email to name, email is name, and then if we check this ID is in email, it's okay, but not, we needed to make a new one. So current email not in email to ID, I will generate email to ID, email is index, and then I increase index. Then if we found, we just the union. Which one? First, I will union first email to next one. So in this case, first one is email to ID, get email. First email, what is first email? A1 with email to ID current email. Now this one will be same group. And then one more good thing. Okay, let's check now is here. This time email is this one, right? So we put the John is email, and then next in this case email is not in ID. No, because this one is already generated, so we able to get this one ID. So combine this one with this one. So finally this one has same ID. Does this make sense? So it's going to here. Alright, so now it's time to generate sentence to output. So first I'm gonna make output is must be collections default dig, because I like to use default dig is list collections. And then where are we able to get email? That's right, email to ID. Email to name is also okay. Yeah, then it is okay. And then output. What is key? Yeah, key is email to ID and email. Just so no, we need to get the ancestor group ID. So to do that, find email ID, open email. Then we able to grouping by group ID. And then finally we need turn. We will get values from for fields in output values. So output values is only must be this one. Because it already merged it. And then key is start with 0, so this is key 1, 2, and then it is in the cache table. So first we are able to get this one, and then this is first spell. How we gonna to make the name? Yes, that's right, we are able to use this one. So I'm gonna use first is this one name is what is bells 0. Because if we get this one and then we able to find, easy to find name, right? And then plus next is we must be sorted right in sorted order. So sorted the bell. Yeah, does this make sense? Okay, let's check the code. Oh, looks good. Okay. Time complexity is, in this case, this one take linear time, because this is union find, and then our count also linear, this one also linear, but we use the sort right. So time complexity is n log n, and then space complexity is we use several hash table. So space complexity is linear space. Thank you.